Now let's take a look at our second problem. This is very much like the first one with two key differences. One is I now have 5 painters instead of 3. That means I now have 5 factorial or 120 cases instead of 6. And personally, I don't want to list out all 120. I could still do that under exam time conditions. Because if I spent 3 seconds per case, both listing it and figuring out what to do with it, that's going to be 6 minutes. It still works out. On the other hand, I'd rather find something a little bit faster because I'm a little bit too lazy to do that. The other key difference is we have to figure out what our strategy is going to be in this case. We're not told what our strategy is. We have to come up with one. So first, let's think of a strategy. I'm going to consider a number of possible strategies. My first strategy I'm going to consider is I will automatically reject painter A exactly as before. And then I do the same thing I did in the previous problem. I'll accept the next bid that's better than a painter number A. Now, as before, I'm still going to ultimately have some cases. I don't want to have 120 different cases. So what I'm going to do is I'm going to let my cases be things like what are the possible values of A. So maybe A is 1, A could be the second best bid, the third best bid, or so on. Now, if I'm breaking something down into cases, I often want to know, well, what are the probabilities of all of my different cases? In this situation, A is equally likely to be the first, second, third, fourth, or fifth best bid. So all those are simply just going to be 1/5. And then, what else do I need to know? I need to know what's the probability that I'm winning? What's the probability I end up getting the best possible bid, conditioned on being in that case? Well, in case 1, if the very best bid is the first bid and I reject it out of hand without thinking about anything else, I'm guaranteed to have lost. If A gave me the second best bid, then what do? I reject A, and then I wait until either I get a better bid or I'm stuck as the last person and I have to go with something. In this case, since A had the second best bid, sooner or later, or the only time I'm going to accept a bid is when I had the best bid, whenever I get somebody who's better. So I'm guaranteed to win in that case. If A had the third best bid, well, who's going to beat that? Either somebody who's first or someone who's second. The first person who beats it will have a 50% chance of being first and a 50% chance of being second because they're equally likely. If A is 4, then it can be beaten by somebody who's bid number 1, bid second best, or the third best bid. Those are equally likely possibilities. So there's a 1/3 chance of the person bid I take being the best, a 1/3 chance of being second best, a 1/3 chance of being the third best. And finally, if A is the worst bid, then I'm going to accept painter B's bid because it's guaranteed to be better. B's bid will be the best only 1/4 of the time. What does this give me as an answer? Well, now the probability that I win, it's 0 times the chance of being in the first case, plus 1 times the chance of being in the second case, a half times the chance of being in the third case, and so on. And when we add all this up, we get 25 out of 60. So that's one strategy. It has a decent chance of success. 25 out of 60 is a little bit better than 40%. Question is, can we do better? So let's try a second strategy. Well, for my second strategy, I'm going to reject A, and I'm also going to reject painter B. So not only am I just ignoring the first painter out of hand, I'm ignoring the second painter out of hand as well, and seeing, does that help me at all? So now what are my different cases going to be? Well, now things are a little bit more complicated because I have 2 painters I rejected. One first case is I could consider, well, what if A or B is equal to 1? What's the probability of that occurring? Well, there's a 1/5 chance that A is equal to 1. If A is equal to 1, then B is 2, 3, 4, or 5. There are 4 possibilities that B can be and still have A be equal to 1. There are 4 possible choices for B. And then I had 2 choices, whether it was A or B that was equal to 1, and those are going to be equally likely in probability. So that's going to give me, when you simplify that, 4/10 as the probability of being in that case. What are some other cases you could have? Next case that we want is maybe A or B is equal to 2, but neither one of them is equal to 1. I'll write that as just saying that the minimum of A and B is equal to 2. What's the chance of that? There's a 1 in 5 probability of A being equal to 2. If A equals 2, in order for the minimum to be 2, B has to be 3, 4, or 5. There are 3 ways that B can be that. There are 4 things that B can be. It can be 1, 3, 4, or 5. And again, then I had 2 choices, which was the 2, which was the non-2. So that's going to give me a probability of 3/10. And then I can do a similar thing with 2 more cases. The minimum could be 3 or 4. Those are all of my possible cases because the minimum of A and B can't be 5 because that requires they both be the worst bid. The worst possible scenario for those 2 people is that one is the 4th worst best bid and one's the 5th bid. And so now what else do I want to add? I want to add on the probability of winning given that I'm in one of these cases. In the first case, when A or B was the best bid, I'm guaranteed to have lost because I've already rejected the best bid. So that's a probability of 0. The second case, A or B had the second best bid, but not the best. So now what's my strategy? I just reject A and B and wait until somebody who's better comes along. Well, if they were the second best, the only way somebody better can come along is if that person who comes along is the best. I'm guaranteed to win in that case. If A or B was the best one of them is the third best bid, I'm going to wait until either the first or second place bid comes along. Half the time I'm going to win because half the time the first place bid will come before the second place bid. Finally, if A and B are 4 and 5, I'm going to accept bid C. C is going to be 1, 2, or 3, each equally likely. There's a 1 in 3 chance of winning in that case. So my overall probability that I win, well, it's 3/10 chance of being in case 2. I'm guaranteed to win in that case. There's a 2/10 chance of winning in case 3. There's a 1/2 probability of winning. And then there's a 1/10 chance of being in case 4 with a 1/3 chance of winning. When you add those up, you get 26 out of 60. So I improved over strategy 1 by a fairly negligible amount, only 1 out of 60, but still, I did do a little bit better, so this is going to be my optimal strategy. That works out to be 0.43 repeating. Well, actually, I skipped ahead a little bit. I said this was my optimal strategy before I considered strategy 3. Right? What's strategy 3? I reject A, B, and C. Do I need to figure out the exact probability of that strategy working? Well, actually I don't, because the probability that I lose is greater than or equal to the probability that A, B, or C is equal to 1. And chance that A, B, or C is equal to 1, well, there are 3/5 of our possibilities. So that's probability 0.6. And so probability that I win is less than or equal to 0.4, which is less than what I had in my previous strategy. So strategy 3, I can quickly see is guaranteed to lose, or guaranteed to be inferior. So my best strategy is strategy 2, and my winning percentage is a little bit more than 43%. We hope you enjoyed these problems. We're planning on initially running this contest roughly once a month, at least in the beginning.